Hello everyone, I am Sonali. In this part we will learn sorting. What is sorting? Why we are using the sorting? Okay, suppose there are a number of elements inside the one array. Okay, so it is necessary to sort this element in a particular order. Okay, we are using this sorting concept in searching also. In previous video, we learned the binary search. Okay, when we are applying the binary search, first it is necessary to sort the data in a specific order. Okay, so at that time we are using the bubble sort to sort the data. So let's see how this sorting is working actually and different terminologies of sorting. Internal sort. What is actually the internal sort? An internal sort is any data sorting process that takes place entirely within the main memory of a computer. Internal sort, the name suggests that internally this process happens internally inside the main memory of a computer. Means here internal sort. This is possible when a data size is small. Okay. It is possible whenever the data to be stored is small enough to all be held in the main memory. Okay. And external sorting. External sorting means what? It is exactly opposite to the internal sorting. This internal sorting is inside the main memory of a computer, and this external sorting is for these we are using the external memory. Okay, used when data to be sorted is so large that we cannot use the computer's internal memory to store it. At that time we are using the secondary storage devices to sort the data. External sorting is used for massive amount of data, and this internal sorting is used for the small data as compared to external sort data. Stable sorting. Stable sorting means what? When we are using this stable sorting, the stable sorting algorithm maintains the relative order of records with equal keys. Means the value. Okay. That is sorting algorithm is stable. When this algorithm is stable, if the order of two records, suppose the two records are R and S. When these records, whenever there are two records R and S with the same key, okay, the key of this element, R element and S element is the same. So when we are arranging this element, when we are sorting this element, it is necessary your S in the original list, okay, R will be the appear before S. Okay, we know that R is, we want R is first and then S is next. Stable sorting. Stable sorting means what? Here we are maintaining the stability. Suppose two records having the same key. Okay, suppose the two records are R and S having the same key. When we are sorting this, when we are applying the algorithm, after this it is necessary R will appear before S in the sorted list. Okay, the stable sorting algorithm maintains a relative order of records with equal keys. This problem occurs when two records having the equal keys. Okay, so at that time it is necessary to maintain the order of this record. Okay, in place sorting. In place sorting means what? This algorithm uses the constant extra spaces for producing the output. We will see the different algorithm for this in place sorting. Okay. It sort the list only by modifying the order of the elements within the list. Next is a comparison based sorting. Comparison based sorting means a sorting algorithm which accesses input array elements only via comparisons. Okay, here this access input array element only via comparison, as is the case for general purpose sorting algorithms. Here we are using the different algorithms like merge sort, quick sort, and heap sort. Okay, here is it one more type, comparison based lower bound. What is mean by comparison based lower bound? See, this means that this omega of analog n is a lower bound for the time complexity of any sorting algorithm that is based on the comparison. Okay, what is the time complexity of this type of algorithm? Omega of n log n. Okay, these are the lower bound. Okay, this algorithm, this specifies the lower bound. Here we will see the first type of sorting is bubble sort. Okay, what is the bubble sort? Why we are using the name bubble? Okay, in this algorithm, smallest element go to the beginning. Okay, smallest element to the beginning. So the name is it's like it's working is like a bubble. So it is a bubble sort algorithm. It is a simple algorithm and it is most popular algorithm. Let's see the bubble sort algorithm. Begin bubble sort. Here is our list. Here is our data. Okay, whole array is here. For all the elements of the list, means we are using the here loop. Okay, for all the elements of the list, compare. Okay, comparison is required. What is the comparison? If list of I is greater than list of I plus 1, means any element, the first element, suppose this is your first element, I equals to 0. If this element is greater than this element, okay, here we are sorting the element. This element is greater than this. Means this is a small and this is large. At that time, we are using the ascending order. First, decide your order of your result, ascending or descending. Then apply this algorithm. Here we are using it for the ascending order. If this element is greater than this, then need to swap this element. Put this element here and list of I plus 1 to here. So use the swapping algorithm, swap list of I, comma list of I plus 1. We know that swap means what? Interchange the value of this and this by using the two variables, or here we are using the three variables to swap these two elements. So our output is next time list of I plus 1 is here and list of I is here. Then end if, end your for loop and return the list, and this is your end of bubble sort. Here number of comparisons are they required for this. See one example. Here the elements 5, 9, 6, 2, 8, 1. These are the different elements of array. Here for the first pass I equals to 1 means what? See, for all elements of a list. So first element, for the first element we will do this first. Okay. So for pass I equals to 1, j equals to 0. Okay, j equals to 0 means what? For the first time. Okay, we are doing the see. Number of times this loop inner loop will execute. Here elements 5, 9, 6, 2, 8, 1. So need to compare first these two elements 5 and 9. Okay, 5 is less than 9. First check it. Yes, 5 is less than 9. So no need to swap this. So on the next line j equals to 1. J 5 is here, 9 is here. Okay, then remaining array 6, 2, 8, 1. Okay, after this, check these two elements, 9 and 6. 9 is less than 6? No. So, need to swap this element. So, in the next step, 5, 6. This 6 is here and 9 is now here. 9 and remaining array as it is 2, 8, 1. Then after this, j equals to 3. 5 is, see, 5 is here, 6 is here, 9 is here. Okay, so here now compare this 9 and 2. 9 is less than 2? No. So swap this. So 2 is here and 9 is here. And remaining array at 8 and 1. Okay. Next step 5, 6. Here 2 is here. Then 8. This 8 is here, 9 is here, and 1 as it is. Okay. How many elements in your array? Check this. 3 plus 3, 6. Okay, 6 elements in this array. So in the first part, suppose the n elements in your array, then n minus 1. Okay, here's number of comparisons required, n minus 1. So compare these two and write the answer of these two in the next stage. So here 5, 6, 2. See, here is 4 till the j equals to 4. 5, only 5 steps inside this. Here 8. Okay, don't write the 9 as it is because the swapping answer 1 is here and now 9 is here. Then again, j equals to 1. Compare first these two as it is. So 5, 6, 2, 8, 1, 9 as it is. Then comparison between 6 and 2. So 5 is here, this is 2 is here, and 6 is here. Then 8 is here, 1, 9. Okay, here. Then after this requires a comparison between these two. So 5, 2, 6 is here, 8 is here, 1, 9. Then again compare between these two. Okay. So comparison need between these two. See, in this step, we will, what is the output of this step? 9. This is the largest element at the end. In this step, this 8, 8. Okay, this is second largest element in this list. See here, third j equals to 0, 5, 2, 6, 1, 9, 8, and 9. Okay, now compare between these two, 5 and 2. So 2 is here, 5 is here. Okay, so remaining array is 6, 1, 8, 9. Then again compare between these two, 5 and 6. So 2 is here, 5 is here, 6 is here, and remaining array is as it is. Then again compare between these two. See, in this step, already two elements at the end. Now 6 is here and 1 will here. Okay. So 2, 5, 1, 6, 8, 9 means 3 elements, largest element at the end. Now again compare between these two first. So what will be the output this? Again, then compare between these two. So 1 will be here and 5 here in the next step. Okay, so 1 is here and 5 is here. Then again j equals to 0, 2, 1, 5, 6, 8, 9. Compare between this 1 and 2. So 1 will be here and 5 is here. How many elements in our list in array? 6. So number of passes required are 5. If n elements, then n minus 1 passes required for sorting the element using bubble sort. Here is your output sorted array 1, 2, 5, 6, 8, 9. In this way, you can try the more example with the help of this solve example and the algorithm. You can use the character strings also here. Solve the data in ascending order using the bubble sort. Okay, your array is, here is a different strings in your array. Okay, so Nanded, Ahmedabad, Pune, Barshi, Lohgaon, Aund. Okay, these are the different city names. Okay, so how to sort this? No need to take whole this. First only compare the first two characters N A A H P U B A L O A U. These are the different. So you can take this. If there are the two more, suppose Ahmedabad and Ahmednagar. Okay, both are the same till the three or four characters. So at that time you need to take the four character. Otherwise only take the only two characters. Okay, only two. Or you can take the only one if all the strings starting with a different character. Then at that time you can take the only one else. But here this A, this is also starting with A, this is also starting with A. So I am taking the two character, first two character of each string. Nanded, Ahmedabad, Pune, Barshi, Lohgaon, Aund. Okay. Consider only these and apply sorting algorithm. How many elements? 3 plus 3, 6. Okay, here is a 6 elements. The number of passes required 5. Okay, you can do. See, do till j equals to 4. This is actually your result step. This is not a part of this. This is your result. You can write it on the next step separately. Okay, directly you can consider it in the next step. In previous example, we have considered this in the next step. Okay, so compare like this. Compare first these two, and here compare the ASCII value of this. Okay, consider this A is capital or small a. Okay, compare this A. Don't compare the ASCII value here. Compare this A with the N. Alphabet A and alphabet N. We know that A is small than the N. So AH is here and A is here. Then again compare between these two in this way, in like this. See, similar example. Here is also the sixth element, but here we are considering the digits, and here we are considering the alphabets. Okay, so compare and sort these elements in ascending order. Try this example. Okay, thank you.